everyone. My name is Zsolt, János, Viharos. I am the presenter of the paper, and I have four co-authors, János, Tamás Csertek. They are here also as picture. And this presentation is about the picto robot, so the face painting robot that you can enjoy in the same floor. But we have a second presentation about this robot. The current presentation is mainly on the vision part and the artificial intelligence part, and the second one is mainly on the robotic realization. I am from the Staki, which is a research institute in Hungary, Institute for Computer Science in Control, which is located in Budapest. And I have also university position here in the John von Neumann University, and my PhD student is a student of the ELTE University. He made many implementation that I will present. And now I start this video. So this is an old video, but you can enjoy it in the real, that your face will be drawn, and you can take with you the paper. So actually it seems to be a simple process, but many actions has to be taken after each other. For example, when we make a picture, we have to find where is the face. This is not a difficult task because when you make a selfie, when you prepare a selfie, then you have also recognition of your face. But anyhow, it is not so easy to recognize it. Then we have image matting. It means removal of the background. We have edge detection, because here we have the edges, as lines. We have to segment the face, and we introduced last year the iris detection, because earlier we haven't detected exactly the iris and the pupil, but we found that the drawings, this is already an improved version drawings were not so human, and that's why we introduced that one. Then we have the edge decaying vectorization, and then we can give it to the robotics. Please draw this face. This will be presented in the robotics TC in TC13 this afternoon. What the robotics aspect. So about the robotics, I don't want to explain. This is a robot what we use. It's a collaborated with 6 aspects. We have a gripper. We have also a sensor. I will explain it. We heavily use the GPU behind, so we need the GPU. Currently, the calculation of all the AI components requires 30 seconds, roughly. Without the GPU, it will be 2 minutes or something like this. So we heavily use the GPU, but it will explain in the other presentation. So this is the step-by-step approach, and here we gave numbers, and here we listed the scientific papers and the related artificial neural network deep neural network models that we apply in the different stages. So the composition of this row of calculations, it is far not clear whether this is the optimal composition. This is the main advantage of the paper that we presented now, how to process the image after each other. So now I go step by step. So the first one is to recognize. Here we have these pictures, but the neural networks don't know where is the face. So finally we can say, okay, here we can select a part of the picture. Here is the face. This is a neural network with, it is called retina phase network. It was trained on 32,000 images, and here are examples. So it is easy, for example, here as a football player, it can recognize the face from different aspects, but usually the drawing is good if you are in front of the face. So this is a first neural network. It is a wider phase network. So all of these neural network architectures, which are trained or pre-trained, they have a special name. The next one, so this is the structure. So it is a 2-component neural network. It is a convolutional neural network. First one is the feature pyramid, so extract features, and second one is the context module to increase the receptive field, and also it improves the results of the first neural network. The next one is a background level removal. So you can see here, we have this green background, but sometimes it is more hell, sometimes it is more dark. So it is not exactly given. Then we have to find where is the border and where is the face. So then this is the results. Then according to this ModNet neural network, which is really interesting, it was trained by 50,000 images, but they were not so exact and accurate images with low resolution, but only 100 images had a high resolution for this training. But now you can see we can eliminate the background. And also in this demonstration on this floor, actually we use a background wall, but it works without the background wall. So we can be on the street or whatever, it works. So it is relatively effective. Unfortunately, sometimes what we recognize, it is removing a part of the hair, even if when a hair is very hell. So this is the ModNet architecture. These are some typical results. So you can see in relative complex cases, it is able to remove the background. And this is the architecture. It has 3 components: semantics, boundary details, and final alphabet that they do. So the calculation behind is a relative complex structure. So it is not so easy to remove the background. So now we have the face. And then next step is with a BI-PED network, which was only trained by 250 images. And here it is a very interesting aspect that from this image we can find the boundaries, the edges. But this neural network was trained not on faces, it was trained on pictures from the street, like cars and trees and windows, even if they work. So it was also our research activity whether they work on faces, but we found, as you can see, it works. Okay, sometimes it is not so accurate, but it works. So this is one of the inventions that is really interesting. Here are examples. So it was trained on such pictures, like a helicopter or a zebra or whatever. This is from a town, and this is what humans have done as training material, and this is the result when the neural network is trained. So you can see human invented, okay, here are the borders, but finally the different lines of the zebra was detected by the algorithm. So it is really interesting that we use for face, even if it was trained, no one face was in the training component, in the training data set of this BI-PED network. The next, and here is the architecture. So you can see this is a typical series convolutional neural network. So here are the convolutional layers. And you can see it starts from the original image, and step by step it is more and more accurate and more strict what they expect as an edge at the end. But in the internal representation, and this is really nice, and in the field of neural networks, we have also a research direction that sometimes they cut here the neural network and substitute another one, but I don't want to go in such details. So this is an important part, really interesting. The next one is the segmentation. So it is not enough for the final image, because if we would have only this, you will have not so nice paintings or drawings that we have here in the demonstration. So we recognize, and this is the Reuter transformer network. I have to mention here this is a kind of transformer network. This is a relative new development for a scientific community. For example, ChatGPT is one of the transformer networks. The previous one was a convolutional neural network architecture. So we detect the different segments of we detect the eyes, we detect the ears, the hair, the ears, and so on and so on. So we know that here are the eyes, here is the nose of the person. So this is a neural network. Here are typical training examples. And here the secret of this network is that the picture from Cartesian coordinates was transferred to the tangent hyperbolicus polar coordinates, like this from this lady was transferred to this lady. But it was more robust to train this neural network. So it identifies the different segments in the picture. structure. I don't want to go into detail, but it is a typical transformer type network. The next one at the beginning, so last year we invented also the pupil and the eye tracking. So as a result, we can detect the pupil and the border of the eye. So it means 16 points here we can detect, and this circle defined by 4 points, which is not a good approach, but this neural network is capable of this, plus this center. So it was, this neural network was trained on the 20,000 images. You can download all of these network models from the internet. When we apply this, and you see the result, it was more human. Otherwise, it will be like a toy, the picture. 2 years ago, it was not so human-oriented or resulted, or the drawings were not so human-related, but now is already. So now we have a fusion. So we have this result, and this result, and this is a fusion. So you can see here the edges, there are segmentations, everything is given now, but it is not good for a robot because these are only pixels, and the robot cannot draw pixels. The robot requires vectors following with splines. So the next one is the classical relative old algorithm, the Zhang-Shuan algorithm, which makes from these pixels lines or thin lines. So this is the main approach. You can see here as a video. I think it is relatively easy to understand. From this high number of pixels, we should have only a lines. And here is the results from the hair. As result, we get that. But still, this is a pixel, but this is already a thin pixel. And from these pixels, we should have lines. And here we use the classical auto-trace method. So we have already lines then that we can draw by the robot. And finally, we have already lines. So we can give these coordinates to the robots. Let's go line by line, and let's draw it. And finally, the next question is, what is the sequence of drawing? And you can see it is considering the classical human approach, it is a total stupid sequence. But here we optimize the speed. So what is the total time of drawing? And here when we move upwards the robot or put it down, it has a special speed. And when we go with the pen, it has another speed. And we have the target picture. Then considering the target pictures, every time some optimization is running to organize it so that it has the highest speed, so you don't have to wait too much for the result. So this is also an optimization task. So you can see this is a chain of relative complex and relative difficult algorithms, and then we can give finally to the robot, okay, let's draw it. And here we have also another component, what we don't use now, is that we have the force control, but actually in the current version we don't use it. It is given, but we will use it later. I will explain shortly. Actually, we are invited in many conferences like Stuttgart Science Festival, but we were also invited to our World Congress. This is a drawing from today. Everyone is welcome. Please advertise this. We are really happy to draw all faces. We have 1,100 visitors of this conference. We have for sure 1,100 A4 papers, so we are ready to draw everyone here in the conference. And what is the future or the short present? We have already some developments here detecting other components of the face. It is not yet finished. What is really interesting, we want to estimate also as an interesting effect the age of the person who is drawn. So so on the drawing, for example, here the estimation is 25 years. We have also a research in Stucky, but one of the recent developments, not to paint with a pencil, but with a pen, but with a pencil. So here you can see, but to making this picture takes 40 to 60 minutes, so 1 hour. So instead of 1 minute here, we can also also do something. Well, it is already given now as the test, but if you want to have this this painting or this drawing, you should wait 1 hour. So, but this is also an option, but this is still on the development, in the development phase, but it is available for everyone. So, thank you very much.